Okay. Today I want to show you this program, which is to work with a serial UART of the 328. And so again, this is for the 328. I better put that up here somewhere in my program to remind us that this is for the 328 as opposed to maybe the Tiny 13 or the ATmega 32. Because each of these chips has slightly different registers. And to see the difference between the registers and the chips, one will need to refer back to the book. Well, again, so in this program, what I want to do is to take a GPS sensor and connect it to our chip. This will allow our chip to receive data pertaining to the global positioning system, like latitude, longitude, altitude, speed, time of day, and other items. So again, the GPS sensor is always outputting this stream of data. We just need to collect it and parse it and post it. We could post it to an LCD screen. So again, the microprocessor, it's going to receive the data and rearrange the data and then post it to an LCD screen. Maybe you are only interested in the time of day, and so one could look for that data only and then present that data. To use the GPS sensor, you'll need to connect the black wire to ground, the red wire to 5 volts, and the yellow wire of our GPS sensor goes to PD0 of the microprocessor. The GPS sensor outputs data on the yellow wire. If you have a different sensor, of course, that color would be certainly different. That's the transmit pin of the sensor. Our computer, the receive pin, again, is on PD0. Once you make the connection, that's pretty much it for the hardware. We'll be using PD0, like I say, as an input. It is not necessary or needed to have the DDRD set up as if you were doing reading a switch. So this is slightly different than digital input and output. We do not need to work with a DDRD. But what we do need to do is, as you can see, I've already typed in some of the registers that pertain to the UART. For example, we need to set the baud rate. And to set the baud rate of the 328, we use these first two registers. Set baud to 4800. Now the reason why I'm using 4800 is because the GPS sensor is at 4800. So these two numbers, the 25 and the 0, according to the book, the table in the book, those are the numbers we use to set the baud rate to 4800. Also, I'm using the double speed, which I'll get to in just a minute. So using the double speed, I need to use a 25 as opposed to a 12. The third line is to use the double speed. So the clock goes as twice as fast as before, and because the clock goes twice as fast, instead of using a 25 count, I'm sorry, let me try again. Instead of using a 12 count here, we use a 25 count, which in this case gives us better resolution and accuracy in order to hit the 4800. When this number here, 25, is smaller, then you're less accurate in terms of getting the right baud rate. So we would really prefer this number to be bigger still. If this number was 100, it would be even more accurate in terms of hitting the 4800 baud rate, which is what we desire. Now remember, the microprocessor has, like a 3% error on the clock. So the clock could be 3% fast, it could be 3% low. That's a good figure to use. So even though we might be using 25 and that 25 might be the perfect number, remember you still have a 3% uncertainty on top of that because of the clock. Next. Okay, on line number 4, I'm looking at this line here, and I typed this in, and this would be fine if you want to transmit from the 328 to something on the outside. But of course we want to receive, so this should be changed to an RX instead of a TX. And now with this will allow us to receive data as opposed to transmit. Now you could do both at the same time if you wish, but I want to just receive. So set up to receive. Now at this point, with these 4 lines, that's kind of like the minimum we need to type in to initialize the computer to be able to receive serial data. Next, it's ready to receive serial data, and you have to wait for the data to come in because the data might not come in for a few minutes. So we have to sit here and wait and wait and wait and wait until the data comes in. That's what the next line does. It looks at this register and it looks at that bit, and when that bit is a 0, that means we don't have any data yet. So again, when that bit's a 0, the data is not there for us. But when the bit becomes a 1, then the data is ready and available for us to use and read. And to read the data that we just received, you do this. You say, for example, character value equals, and this is going to come from the UDR0 register. At this point, the value variable has the letter that was received from the sensor, and we can do something with this letter. If you want to get many letters, then you put this into a loop, and I'll just do this. You can do this, and you can do this, and you see those curly brackets that I put in right there? You could make this into a loop and capture multiple letters, and from that message string, those multiple letters, you could then look at the latitude or longitude or time of day. You would need to refer to the standard or the message string information pertaining to the sensor. So you go to Google, you type in GPS sensor data string, and it will reply to you what the data string looks like. And from that string, you can then know how to parse the data. There's an example of it in the textbook. So in the textbook, you could go to the index and look under the GPS sensor, and it will tell you what this data string will look like. Well, I just built or compiled the program, and it didn't have any errors, so it looks pretty good. And again, this is an example of where you can set up the serial data port to receive serial data. Don't forget to connect your sensor. You don't need the DDRD. We set the baud rate, and then we wait for the character to arrive, and once it arrives, we can then get the value from the UDR0 register.